A Science Wiz production.
You ever wondered what everything around you is made up of? And by everything, I don't just mean the non-living things you can find around in your house. I mean literally everything that exists in this universe, including
Cars, planes, phones, birds, cows, us humans.
well, curiosity in the world is dying. Less people are curious these days. So maybe you haven't wondered what everything's made up of. Well, let me tell you something astonishing. Everything in the world is made up of one type of thing. Yes, everything in the world is made up of only one type of thing.
And those things that we're talking about here are called atoms. Atoms are microscopic, meaning that we can't see them with our naked eyes. We need something like a microscope to see them. They make up everything in the universe, as I just said. But atoms aren't the smallest things in the universe. They can also be broken down. They consist of smaller particles found inside them called electrons, neutrons, and protons, which we will discuss about later. Here is a diagram of an atom. The center of an atom is called a nucleus. Inside the nucleus are two types of particles: protons, which have a positive charge, and neutrons, which have no charge. Particles called electrons, which are negatively charged, orbit or spin around the nucleus. The orbital paths are called shells.
Okay, so atoms can be broken down into particles called electrons, neutrons, and protons. But did you ever know that electrons, neutrons, and protons can also be broken down into something?
Electrons, protons, and neutrons are called subatomic particles. Well then, what are the particles that subatomic particles are broken down into called? Subatomic particles?
Subatomic particles such as electrons, protons, and neutrons are broken down into rather weird things called quarks.
Quarks are found inside protons and neutrons.
All this physics, it's very interesting, isn't it? I think it is. So why don't we go ahead and explore even more types of subatomic particles? To learn about even more types of subatomic particles, we'll need to explore something called the Standard Model of Physics. Because as we learn about the Standard Model of Physics, we're also going to learn about new types of subatomic particles.
So let's learn about the Standard Model of Physics. Here's what the Standard Model looks like. It's like a periodic table which classifies subatomic particles, not elements. Let's study it bit by bit. Let's first look at the blue and the green sections of the Standard Model. These subatomic particles are called the fermions. They're broken down into two groups, the quarks and the leptons. Let's look at the quarks first. They exist in three groups or generations. Each generation of quarks has two types of quarks. In total, there are 6 types of quarks. They have very weird and unorthodox names, and each generation has quarks heavier than the previous generation. The first generation of quarks consists of the up quark and the down quark. Up quarks and down quarks make up protons and neutrons. A proton is made up of 1 up and 2 downs, while a neutron is made up of 2 downs and 1 up. The up quark was theorized by Murray Gell-Mann and George Zweig in 1964, and it was discovered in the SLAC National Accelerator Laboratory in 1968. The down quark was theorized by the same people and also discovered in the same laboratory. The second generation consists of the charm quark and the strange quark. Again, this generation is greater in mass than the first generation. The charm was theorized by Sheldon Glashow, John Iliopoulos, and Luciano Maiani in 1970. It was discovered by Burton Richter at SLAC and Samuel Ting at BNL in 1974. The strange was theorized and discovered by the same people who theorized and discovered the up and the down quarks. The third generation consists of two types of quarks, the top quark and the bottom quark, and again the third generation is greater in mass than the second generation of quarks. The top was theorized by Makoto Kobayashi and Toshihide Masukawa in 1963, and it was discovered during 1995 in collaborations between the CDF and an experiment called the DO experiment. The bottom was theorized by the same people who theorized the top, and it was discovered by Leon M. Lederman in 1997. We've looked at the quarks now. Let's look at the leptons now. They also exist in 3 generations like the quarks. 2 leptons exist in each generation, and in total there are 6 types of leptons. The first generation has the electron and the electron neutrino. The electron neutrino is basically an electron with no charge. We haven't yet discovered the mass of any kind of neutrino. The electron was theorized by Richard Laming during 1838 to 1851, and G. John Stoney in 1874, and many other people. The electron was discovered by J.J. Thomson in 1897. The electron neutrino was theorized by Wolfgang Pauli in 1930 and was discovered by Clyde Cowan and Frederick Rains in 1956. Second generation has the muon and the muon neutrino, and the muon neutrino is basically a muon with no charge. The muon was discovered by Carl D. Anderson and Seth Nedemir in 1936. The muon neutrino was theorized during the 1940s and was discovered by Leon Lederman, Melvin Schwartz, and Jack Steinberger in 1962. The third generation consists of the tau and the tau neutrino. The tau neutrino again is a tau with no charge. The tau was discovered by Martin Lewis Pearl in 1975, and the tau neutrino was theorized somewhere during the mid-1970s. It was discovered in the donut experiment collaboration in 2000. A rather weird name for an experiment, right? The donut experiment. Now, we've looked at the fermions, but we haven't looked at whatever these things are called bosons. Let's look at the bosons now. The bosons include the photon, which carries electromagnetic force, the W and Z boson, which both carry the weak nuclear force, and the gluon, which carries the strong nuclear force. The Higgs boson gives mass to things. Let's look at hadrons. Hadrons are a very easy concept. They are basically just particles made up of quarks. There are 2 types of hadrons, the baryons and the mesons. A baryon is made up of any 3 types of quarks. Protons and neutrons are examples of baryons. A meson is made up of a quark and an antiquark. If you don't know what an antiquark is, don't worry, we'll discover about that in another video.
Phew, that was a lot of information, wasn't it? It was indeed. But don't worry, I'm not going to load you with more information, because that was all you need to know about the standard model of physics. I hope you enjoyed the video.
But wait! Just a couple of reminders. Don't forget to look at my website, which is thesciencewiz.wixsite.com/thesciencewiz. I know it's a long URL, but I just couldn't change it. And also, please don't forget to subscribe to my channel. Thanks for watching! A Science Wiz production.